So here is the 2012 8B. A string is wrapped around a smooth pulley wheel of radius r. A particle of mass m is attached to the string. The axis of rotation of the wheel is perpendicular to the wheel and passes through the center of the wheel. So what does that basically mean? Basically means we're just going around in a circle. Okay, it's not moving about its center. Okay, so that's handy enough to understand. Now, the moment of inertia about the axis is I. The particle is released from rest and moves vertically downwards. Find in terms of I, m and r the tension in the string. Okay, so let's begin. We have two different types of energy going on here. Okay, the first one is the rotational energy of the wheel is a half I/W squared. That in turn is added on to the kinetic energy of the moving particle, which in turn, all this energy comes from mgh. In this case, mgh represents potential energy and the mass of the mass above the ground. Okay? Now, where does it say the mass starts from? We don't know the distance. We don't know how long this line is. Okay, so we just have to figure out how far it falls. Okay, so we next got to figure out is what is W or omega. Omega represents the angular velocity. It's equal to phi over r. Or in your equation you might have phi equals r omega. Okay, omega equals phi over r. This converts this formula into a half phi squared over r squared now. Okay, plus a half mv squared equals mgh. And then what we can do next is we can just tidy that up a little bit, and what we're going to get is a half 1 over 2 r squared iv squared plus a half mv squared equals mgh. Okay, handy enough. Next part, phi squared equals u squared plus 2as. This is regards to the velocity of the particle. Now, what you also need to know about the velocity of the particle is we're not actually using s, we're using the height it falls. So the height it falls represents h. Okay, so if the particle falls a bit more, sorry, if the particle starts here and if it falls down to, let's say, down here, that represents a fall in h, a drop in height of h. Okay, so what we're going to do here is we're going to change that to h. Okay, starts off at rest. This means phi squared equals 2ah. Look up at the start. There is no sign of phi in this question. Let's get rid of phi squared right away. So what we're going to have here is going to be a half 1 over 2r squared, and it's going to be I over 2r squared phi squared, which is 2ah, plus a half m times 2ah equals mgh. Okay, the 2's will cancel. Okay, and what we're going to get next is IAH all over r squared plus MAH equals MGH. Now the h's are going to cancel. Okay, next thing we're asked to do is we're asked to get the we're going to be asked to get the acceleration on its own. Okay, so if we can just write down one thing, by the way, before we begin. T equals, we're going to do the formula for m. Okay, the formula for the particle m. Tension going upwards, mg going downwards. So basically T minus mg equals ma. So if we isolate A, guys, if we isolate A, then there's a clear route for T, isn't there? because T equals MA plus MG. So we're just going to write this down underneath to explain what step we're making next. T equals MA plus MG. Because remember, initially MA equals sorry, just give me a sec, that's the wrong way around, isn't it? Yeah, so it's MG minus T equals MA, excuse me. Yeah, sorry. MG minus T equals MA. So this means T equals MG minus MA. Okay, so it's going to be MG minus MA, excuse me. MG minus MA. So this is MG minus MA. Now that I've done that, let's isolate A on its own. Okay, it's going to be bracket A into 1 over I over R squared plus plus M equals MG. A therefore is MG divided by I over R squared plus M. Might help for us to tidy this up a little bit. So A equals MG, give them a common denominator, I plus MR squared all over R squared. Bring the R squared to the top, so we're going to get MG R squared divided by I plus MR squared. So that's what A is. Now, once we've found out what A is, we've got to insert that into the formula I was just talking about a second ago, where T is going to be MG minus MA, and what I'm going to get is T equals MG minus M times MGR squared all over I plus MR squared. Now, did it give me a specific proof? It didn't. So you could be entitled to leave it like that. I'd be entitled, I would factorise out the MG, and what I'd be left with is MG into 1 minus MR squared all over I plus MR squared. Okay. That is okay. So we're going to break this down further. We're going to get a common denominator. So we're going to get T into MG, and now we're going to get I plus MR squared minus MR squared all over I plus MR squared. Cancel. And what we're going to get T is equal to is MGI all over I plus MR squared. Okay guys, what next tells me is that the acceleration is G over 5. Okay, and this is part 2, and what it tells me from earlier is we already had an equation for that. We know that G acceleration equals mgr squared all over I plus mr squared. So what we can find out first is that the G will cancel, okay, and we need to think of what to isolate. Okay, it might be a good idea to isolate I, because I at the end of the day is the inertia, and inertia links back to the mass. Okay, so let's isolate I. Cross multiply I plus mr squared, multiply up to 5 equals 5 mr squared. Bring the mr squared out to your side, I equals 4 mr squared. Okay? Now remember, the formula for inertia is a half mr squared, where m represents the mass of the system. The r squareds will cancel. A half a capital M must be 4m. This means that capital M, or the mass of the system, or mass of the wheel, must be A then. This formula comes from the inertia of the disc. It's a circular disc at the end of the day, and the inertia of a disc is a half its mass or squared. Okay guys.